If you walk up to a modern sliding wardrobe and give the edge a gentle push, the mirrored panel glides away in near silence. It feels effortless. That smooth motion is the result of a specific mechanical trade-off. This door panel can weigh up to 120 kilograms, the weight of 2 adult humans, yet the force required to initiate the glide is negligible. The push to develop this technology came from a shift in urban geography. As city apartments shrank, the traditional hinged door became a liability. Opening one required a wide, empty arc of floor space, a swing radius, that was suddenly too valuable to waste. To reclaim that floor area, designers had to turn a heavy, static wall into a mobile partition. The challenge was finding a way to move that much mass within the footprint of a single track. The ease of use hides the high-tension mechanics required to manage that weight, just out of your line of sight. To understand how that mass is managed, we have to look behind the panel and into the track system, where the primary obstacle is friction. Early sliding designs used a bottom-running system. In this setup, the entire 120-kilogram load pushes downward onto a set of rollers sitting on a floor track. Because the weight rests on the floor, the system is sensitive to the environment. If the floor slants, the door rolls on its own. If there is thick carpet, the track sinks under the weight, causing the rollers to bind and the system to stall. In a top-running system, the engineering is reversed. The weight is suspended from the ceiling inside an upper carriage. By shifting the load upward, the door hangs freely. Friction is reduced to a few engineered nylon wheels gliding along a rigid track. However, hanging a heavy mass from the ceiling makes it prone to swinging. Engineers address this with a T-guide, a small plastic peg on the floor that fits into a narrow groove carved into the bottom of the door. The T-guide removes the need for a full bottom track. It doesn't support any weight. It simply keeps the suspended door from moving like a pendulum. By moving the load to the ceiling, the door becomes a structural extension of the architecture, hanging from the frame rather than the floor. As track mechanisms improved, designers focused on making these heavy doors blend into the room, aiming for perfectly flush, seamless walls. This top-down view shows the sequence of a coplanar system. When closed, the doors sit in a single line. When you open it, the panel mechanically pops outward to clear the adjacent door before sliding sideways. The flush pocket system takes this further by hiding the door inside the wall itself. These use push-to-open spring latchets that eject the heavy door from its recess with a single tap. These systems function as architectural tools. They hide the physical footprint of a heavy barrier until the moment it is needed. Reducing friction for a 120-kilogram object introduces a safety risk. Once that mass is moving, it becomes a projectile. If the door hits the end of the track unmitigated, the kinetic energy can snap the mounting hardware or cause a derailment. To prevent this, tracks are equipped with anti-jump technology. These are locking mechanisms that hook under the rail, ensuring the rollers stay attached to the track even under high-impact stress. Stopping that momentum safely requires more than a simple rubber bumper. The system has to absorb and dissipate the energy of the moving mass. This diagram shows a soft-close hydraulic damper with fluid chambers, a piston, and a spring coil. An actuator engages the damper as the door closes. The piston compresses, bleeding kinetic energy by forcing oil through tiny valves. A secondary spring pulls the door shut. A high-end sliding door is essentially an industrial shock absorption system designed to safely arrest that momentum. For all the sophistication of these tracks and dampers, the sliding wardrobe is defined by one specific layout constraint: the doors must overlap. Because the panels occupy parallel tracks, one door is always parked in front of another. This creates a permanent physical limitation, the blind spot. You can access the left side or the right side, but never the entire contents. One half of the system always obscures the other. It is a clear trade-off. We use suspended tracks and hydraulic dampers so storage remains hidden. Ultimately, the modern sliding door trades absolute visibility for the floor space required to live in a modern urban environment.